Imagine this. One ordinary day, the Earth suddenly stops spinning. Not for an hour, not for a day, but for just 60 seconds. That's all it takes. In the blink of an eye, everything you know about motion, balance, and gravity goes out the window. Cars are hurled off roads as the momentum of our planet throws them like toys. Oceans surge like unstoppable tidal waves, smashing into coastlines with a force that reshapes continents in an instant. Skyscrapers, bridges, and trees, nothing is anchored enough to survive the sudden halt. For a full minute, the air itself becomes a raging, invisible tsunami, whipping across the planet at speeds that could flatten entire cities. Mountains feel the tug of a different kind of gravity. Rivers reverse course. The sky itself seems to convulse, as the balance between the Earth's rotation and its orbit around the sun is thrown into chaotic tension. And you? You'd feel the world's momentum like never before, your body pinned, thrown, or tossed in ways our brains weren't designed to handle. 60 seconds might sound brief, but in that single minute, Earth's machinery, a system that has been perfectly balanced for billions of years, experiences a shockwave of catastrophic consequences. This isn't science fiction, it's physics, gravity, and inertia combined in a terrifyingly real scenario. The Earth's spin isn't just a motion in space, it's the heartbeat of our planet, and if that heartbeat pauses, even for a minute, nothing will remain the same. Please like this video, subscribe to the channel, and comment your question below. Let's step back and imagine exactly what it means for Earth to stop rotating. Our planet spins at an astonishing speed, roughly 1,670 kilometers per hour at the equator. That rotation is what gives us day and night, what shapes weather patterns, and even what keeps oceans from piling up at the poles. Now, picture that spin grinding to a sudden stop, just for 60 seconds. Why is this scientifically fascinating? Because it's not about science fiction, it's about inertia and momentum. Everything on Earth, from oceans to tectonic plates to the atmosphere, is moving with the planet. When that movement suddenly halts, the effects ripple outward in ways that defy intuition. A minute may sound short, but in physics, that's an eternity when dealing with the forces generated by a spinning planet. In this video, we're going to explore what would happen step by step. We'll look at the immediate catastrophic events, the chain reactions that follow, and the long term consequences that could redefine life on Earth as we know it. You'll see why the spin of our planet is not just a backdrop to life. It's a safety mechanism, a stabilizer for everything from climate to gravity's grip. By the end, you'll understand that stopping Earth for just a single minute is far more than a theoretical thought experiment. It's a glimpse into a chaotic, high stakes reality that could transform our planet in ways you've never imagined. The first and most immediate consequence of Earth suddenly stopping its rotation is a catastrophic surge of momentum. Everything on the planet is moving along with the spin, even the air, the oceans, and every object not rigidly anchored to the ground. When the Earth halts, all of that momentum doesn't just vanish. It keeps moving forward, creating an unstoppable wave of destruction. Imagine standing near a coastline. The oceans, previously held in place by the centrifugal force of Earth's rotation, would surge inland at unimaginable speeds. Waves hundreds of meters high could crash into cities and forests alike, reshaping landscapes in seconds. Inland, vehicles, trees, and even buildings that aren't anchored to bedrock would be thrown sideways. Inertia doesn't discriminate; anything not bolted down becomes a projectile. The atmosphere reacts similarly. Winds that were once a gentle breeze now transform into supersonic gusts, sweeping across continents at over 1,500 kilometers per hour near the equator. Even small hills could turn into lethal barriers, and entire forests could be stripped bare in moments. The sky itself might seem to twist as air masses collide in swirling chaos. Geology also comes into play. Tectonic plates, constantly nudged by the planet's spin, could experience sudden shifts. Earthquakes would ripple across fault lines as stresses build and release all at once. Volcanic systems, sensitive to changes in Earth's crust and mantle, might erupt due to the sudden redistribution of forces. This is more than a cinematic disaster, it's pure physics in action. The forces unleashed would dwarf most natural disasters we've ever recorded. Even a minute is enough to transform cities into wastelands, flatten forests, and send rivers in reverse. For one terrifying 60 seconds, the planet itself becomes a chaotic storm of momentum, energy, and destruction, proof that Earth's rotation is not just a motion, but a life-sustaining force. Once the initial surge of momentum subsides, the second major consequence begins: environmental chaos on a global scale. The sudden halt of Earth's spin doesn't just fling objects around, it radically alters the balance of oceans, atmosphere, and climate. Oceans, previously bulging at the equator due to centrifugal force, would start rushing toward the poles. Water levels along coastlines could drop dramatically in some areas, while elsewhere massive floods sweep inland. Entire island nations could disappear in minutes as the oceans redistribute. Rivers and lakes would overflow, creating temporary inland tsunamis that carve through cities and farmlands. The atmosphere would be just as unpredictable. Without the Coriolis effect, which normally drives wind patterns and storms weather systems, would collapse into chaos. Hurricanes could spin in unusual directions, tornadoes could form unexpectedly in regions that rarely see them, and jet streams could violently shift, causing unprecedented storms. For the 60 seconds the Earth isn't spinning, pockets of extreme pressure would build and release in a domino effect, generating winds and turbulence that seem almost supernatural. Even the land itself reacts. Soil, sediment, and loose rock, previously stabilized by gravity and rotation, could slide in massive landslides across mountains and valleys. Glaciers might crack under new stresses, releasing torrents of ice and water. And don't forget tectonic activity. The sudden redistribution of mass on Earth could trigger earthquakes along already stressed fault lines, sometimes miles away from the initial momentum surge. The chain reaction doesn't end when the minute is up. Once the planet starts spinning again, the system doesn't reset instantly. Storms, floods, and seismic disturbances continue for hours, days, or even weeks. Ecosystems that rely on seasonal patterns, tides, and stable weather are thrown into immediate upheaval. Humans and wildlife alike would face the cascading consequences of a planet that just paused mid motion and lived to tell the tale, if they're lucky. In short, the Earth's temporary stop is far from a minor hiccup. It's a planet wide stress test, a dramatic reminder of how precariously life balances on a rotating sphere. After the immediate chaos fades and Earth resumes its rotation, the long term consequences begin to unfold. A single minute may seem fleeting, but for our planet, even a 60-second pause creates lingering effects that could last for years. First, consider climate and weather patterns. The disruption of the Coriolis effect and atmospheric circulation would leave jet streams and trade winds in disarray. Storms would continue to form in unpredictable regions, some unprecedented in intensity. Entire agricultural zones could fail as rainfall becomes erratic, triggering food shortages. Ocean currents, now shifted due to the temporary redistribution of water, might take months or even years to stabilize, affecting global climate patterns and marine ecosystems. Tectonics and geology would also bear the mark of this event. Fault lines stressed by the sudden stop could experience aftershocks long after the rotation resumes. Volcanoes that were destabilized might erupt unexpectedly, scattering ash across continents. Landslides and glacier collapses set in motion during the pause could continue reshaping landscapes, altering rivers and valleys permanently. Life itself faces challenges. Many species rely on day night cycles for survival. A sudden pause could disrupt mating, feeding, and migration patterns. For humans, the destruction from the initial momentum surge and environmental chaos would demand massive rebuilding efforts, potentially displacing millions. Cities near coastlines or fault lines would face the brunt of these changes, while inland areas would grapple with altered weather and resource scarcity. But the most startling long term effect may be Earth's own balance. Even a temporary pause could slightly alter the planet's axial tilt or rotational speed, creating subtle shifts in seasons and day length. These small changes compound over time, making the world a slightly different place than it was before, even if we rebuild everything else. Ultimately, stopping Earth for just 60 seconds is far more than a momentary catastrophe. It's a reminder that our planet is a finely tuned system, where rotation, gravity, and motion are inseparable from life itself. Even a minute of interruption can echo across continents, oceans, and generations. Let's take a step back and review what would happen if the Earth suddenly stopped rotating for just 60 seconds. First, the immediate chaos. The momentum of everything on the planet, oceans, air, and objects on land, would create catastrophic waves, supersonic winds, and mass destruction in every direction. Cities, forests, and vehicles wouldn't stand a chance against forces generated by a spinning planet brought to an abrupt halt. Next, to the environmental ripple effects. Oceans rushing toward the poles, rivers overflowing, and storms spinning unpredictably. Landslides, earthquakes, and glacial collapses would reshape continents, while ecosystems and human infrastructure struggled to cope. The planet itself would feel the strain, a chain reaction of geological and atmospheric instability stretching far beyond the initial minute. Finally, the long term consequences, disrupted climates, altered ocean currents, and subtle changes in Earth's axial tilt could affect seasons, weather, and life cycles for years. Species, crops, and human settlements would face ongoing challenges, highlighting how dependent life is on the constant spin of our planet. Even a short pause is enough to leave a lasting imprint. In the end, Earth's rotation isn't just a background detail of daily life, it's a fundamental stabilizer, the invisible rhythm that keeps our world habitable. Stopping it, even briefly, reveals how delicately balanced our planet truly is. It's a powerful reminder. The forces that shape our planet are constant, invisible, and often taken for granted. but their absence, even for a minute, would be catastrophic beyond imagination.